So now in this question, we have one differential equation. You can see that here. And it is said that you have to solve this differential equation by something called as Taylor series method. So we'll apply Taylor series method. And if you will see that there are some initial conditions given, okay, those are x naught is equal to 0 and y naught is equal to 0.2. And then there is one more question, find approximate value of y for x is equal to 0.4. So before starting this question, let me explain this a little bit. So when you say dy by dx, okay, it is like this. X is your independent variable and y is a dependent variable. This is x and this is y. We are familiar with this, right? Now, in this case, we know that when x is 0, x is equal to 0 is this point. The value of y is this vertical value, right? The value of y is going to be 0.2. Okay, and that's like one condition is already given to you. And for Taylor series method, we can make a use of this condition and we can solve this. Now just see how we solve this. This is the standard expression for Taylor series. Let me write down the expression of Taylor series. Just remember one thing, that you sometimes write this as a y, or y is exactly same as f of x. What I'm trying to say is whether you write f of x or you write y, it's the same thing. Okay, just make a note of that point. Now let me write down the standard expression of a Taylor series. It is like this. Y is equal to, we start with y naught, okay, that's the initial value, plus x dash plus x y naught dash plus x square upon 2 factorial y naught double dash plus the next one will be x cube. There is a series, right? So you can always imagine x cube after x square will be x cube over 3 factorial and y triple derivative naught and so on. Now that's a Taylor series. All right. So now what we have to do is from this equation here, if you see this equation, we will replace this dy by dx as y prime, or you can say y dash. Okay. And this y dash is equal to 1 plus xy. Now I just want you to understand that we already have a y0 or y naught as 0.2. Okay. This I get it because it is given over here. You can see that here. Okay. Now, next thing that I want here is y naught dash. Okay. So I already have y dash. So if I have to find out y naught dash, okay, I have to put x is equal to x naught, and mind you, x naught value is 0, and y is equal to y naught, and y naught's value is 0.2. So y naught dash, which is this value here, okay, that will be equal to 1 will remain as it is. X will become x naught and x naught is 0, right? So this is going to be 0 and y will become y naught. So this is 0 into 0.2. Of course, this term will be 0 and then you'll get y naught dash is equal to 1. That's the answer that we got. All right. So now once you get this, we have to just keep on solving like this. Once again, you differentiate with respect to x. Okay. So if I differentiate this with respect to x, I'll get the derivative of y dash, which is already y dash, it will become y double dash, is equal to the derivative of 1 will be 0. And for this term, you will do u into v rule. So x into y, if you have to differentiate, x remain as it is, uv rule, right? The product rule. So x remains as it is, the derivative of y is y dash. And then next will be y remains as it is, and derivative of x is just going to be 1. Okay. Now, once we do that, if you got y double dash, now in this equation also, you put x is equal to x naught, x equal to x naught, and x naught is 0, and y is equal to y naught, and y naught is 0.2. So you'll get this as y double dash naught. Now, from this equation, you will have to write down the y double dash will become y double dash naught, right? Equal to the first term has got x, right? And the x value becomes 0. So this the first term was already 0. Then this term will also become 0. Okay. and then this y term will become y naught. I hope you are following this. The value of x naught is going to be 0 anyways. So this term became 0. This was already 0. So what remains is just this y term. Okay. And the y value we are substituting as y naught, and which is essentially 0.2. Okay. So let's now write it down properly. This is going to be 0.2 again. So y double dash naught is also 0.2. Right. And let's do one more differentiation here. If I once again differentiate this with respect to x, I will get this as y triple dash. That's the third derivative of y double dash. We differentiate one more time, so it becomes y triple dash. And then you will again use product rule for these two, and then differentiate y. Okay, let's use the product rule here. So it becomes x y double dash plus y double dash as it is. Derivative of x is going to be 1, and that's u into v, the product rule over here, and this will become y dash, right? And now once again you do the substitution, x equal to x naught, which is 0, and y equal to y naught, which is 0.2. Okay, now once you do that, you will get y triple dash naught is equal to, well, the first term has x, and the x value will become 0 anyways. The first term becomes 0. This term is gone. Y dash will become, y is y naught, so y dash has to be y naught dash. I hope you get that. Oh, it's y dash and y dash. I can simply add them, right? So now this will become y dash naught plus y dash naught, which is 2 y dash naught. Okay, y dash 0, whatever you call it. And then this is 2, and y dash 0 is over here. Can you see that? Y dash of 0 is 1. So I'll put that 1 here. Okay, so I'll get this as 1. So 2 times 1 is going to be just 2. So I got y triple dash 0 is equal to 2. Okay, I'm sure you can imagine that I can just like keep on going like this. Okay, but we can really stop after we get to the third iteration. I think it is good enough. And all these values that you see over here, all these values, if you see, y0, y dash of 0, y double dash of 0, y triple dash of 0, y triple dash of 0, third derivative of y, and the initial value. So all that means is equal to 2. So we have all these values, right? And we can substitute them here. So let's just substitute all the values over here. Okay, all these values here. And then let's just call this equation as, say, let's say A, which is nothing but Taylor series. So from equation A, okay, we will get this as y equal to, let's put the values, y naught, the value of y naught is 0.2. This is 0.2 plus this is x y naught dash will be 1 plus x square upon 2 factorial. Y naught double dash is going to be 0.2. This is 0.2 plus x cube upon 3 factorial. Y naught triple dash is going to be 2. So this is 2, and so on and so forth. So this is basically an expression that we have got. All right. So this is the expression for y, which is written in terms of the powers of x. And I hope you can understand, as you go further away from here, it becomes lower and lower. It gets smaller and smaller. Once that happens, the next thing you will do is, so we actually found out the solution. Now this y here itself is the solution. And this solution is of the differential equation that is given to us over here. Okay. But then if you see the last line, we are supposed to also find out the approximate value of y when x is equal to 0.4. So now from this, you have to find out y when x is equal to 0.4. I'm sure you can imagine how we will do this. If you have x is equal to 0.4, you already have an equation of y that is in terms of x. Just replace all x by 0.4. Okay, so let me write this. It is going to be 0.2 plus 0.4. Okay, that is the value of x that I replaced over here. And then this will be 0.2 the whole square. Sorry, 0.4 the whole square divided by 2 factorial times 0.2 and then 0.4 the whole cube. Do you see this number will be very, very small. So it will really not matter so much, upon 3 factorial times 2 and so on. Okay. And the simplification of this term, I will leave it to you. Just add these terms and you will get the final answer. And this will be value of y when x is 0.4 based on the solution we've got. We've got this solution. And based on this solution, we know that the value of y at x equal to 0.4 will be so much. That is the sum of all these numbers. Okay. Taylor series is one of the technique of solving a differential equation. So originally, if you see that we have a differential equation over here. Okay. Do you see this is a differential equation? And we have actually used this whole Taylor series. It's a power series, right? So we have used the Taylor series, and using Taylor series, we have actually got the solution of the differential equation. And I hope you followed. This is one of the method. All right.